This is new, isn't it? What are you doing? That stopped as well.
Yeah, it stopped in that direction. Ladies and gentlemen, hello and welcome back to Dubious Engineering. So, I want to take you through the entire process of making my very own AM radio receiver. It's a bit quirky. It's got big red knobs on it and an interesting looking sort of tuning capacitor and ferrite rod antenna. But it does what it says on the tin. Eventually, it receives radio. And it's based around the ZN414 and LM358 chips that are easily available out in the marketplace today. So, without further ado, let's have a look and see how this was done. You may be able to see here I have a ferrite rod style antenna and a tuning capacitor. This is an air-spaced tuning capacitor. This one I got out of an old valve radio. This one came out of a slightly more modern transistor radio. But either way, both of those radios didn't work. They were beyond repair. So I salvaged the components out of them. We have an oscilloscope. And we have the Hantech 2D72 handheld oscilloscope, but currently that's just being used as a function generator, as a waveform generator. It's outputting a sine wave at 700 kilohertz. Now, if you watch the waveform, you can see it peak up and then come down, peak up and then come down, and that is virtually at the end of travel, completely open for that capacitor. So 700 kilohertz is one end, and if we just turn that capacitor all the way down there, so that's maximum capacitance now. And what we're going to do here, we'll just turn the frequency down until the point we get a waveform that is of a similar amplitude. Oh, and there she is, and you can see where the peak was. That's about the peak there. But anyway, from about 300 megahertz to about 700 megahertz is our tuning range with this capacitor and coil. The way this is all configured, if you can see it and the camera will focus. So the way this is all configured, we have the tank circuit here, so that's the coil and the capacitor, the tuning capacitor. We have a resistor, there's a 1K resistor on the bottom of that. We have an exciter, which is the function generator, the Hantech function generator there, pumping a waveform into it, pumping a sine wave into it, and we can vary the frequency of that. And then we have an oscilloscope connected across the actual tank itself, the tuning tank, to see where we are. So that then shows us that we're in the medium wave, a sort of frequency band. We're not perfect, but we're not a million miles away from it. We're going to be working on the LM358 amplifier. And what I'm doing, I'm just going to fit the chip to the breadboard. But before I do that, I need to just use a little drill bit to get rid of some of those tracks, to cut those tracks effectively, so that the pins on the chip run in this direction and that direction. This is quite an easy job. There we go, that looks pretty good. So now what we've got to do, we've got to solder the chip in place. And the idea really of this radio is to make a radio that works with a loudspeaker with a small amount of components. So a little TRF radio receiver. That's a tuned radio frequency receiver. And that's ultimately what we're doing. There it is. And it's this way up. you'll see that there's a little tiny cutout in that chip, and that indicates that this here is pin 1, 2, 3, 4 across to 5, 6, 7, 8 back up the other side. So let's have a quick look. I haven't finished this circuit yet, but I've been finding the appropriate components. So we need an input capacitor, a DC blocking capacitor. This allows the audio frequencies to travel down this cable into the input of the LM386 audio amplifier chip, and it blocks any DC signal that might be on here. Then what we have here is we have a gain control. Now I'm just going to go with maximum gain, which is 200 times gain on this LM386. We might find that that is a little bit too much, and in which case we'll go ahead and we'll put a resistor in there. But I don't expect the signals to be particularly loud coming in here. So I think we will probably need maximum gain out of this amplifier. Then we have a little DC blocker for the speaker, and this needs to be a little bit more substantial, but ultimately then this is the output capacitor, and here's a speaker. And then we have another capacitor here which goes across the positive rail. This will be something like 8 volts and 0 volts here, and this will just help make sure that those supply lines are taken care of. We might actually not need this. Anyway, here's the speaker, and this has taken, it's quite a nice quality speaker actually. You can see that by the depth, or look how thick that speaker is, and it was taken out of a little Bluetooth phone amplifier. But that'll get connected up. So let's go ahead, wire this circuit up. I'll quickly talk you through the circuit once it's all done, and then we can go ahead and test the circuit, and that'll be good fun. Strangely, there you go, 2 and 4 connected to ground. This is at 0 volts. This up here is a plus, a VE, or positive. We did put a smoothing capacitor in there. We've got a speaker connected via a 330 microfarad DC blocker on pin 5, which is the output of the LM386. These two guys here are doing absolutely no. This guy here, pin 6, goes up to positive. This guy here, which is pin 7, is doing nothing, it's just left disconnected. We've put a 10 microfarad capacitor in between pin 1 and 8, which actually gives us 200 times amplification. You're gonna laugh when you see me turn this thing on. Then pins 2 and 4 are connected to ground, and there's the DC blocker input. Right, okay. Watch this. Watch this. Let me get this out of the way, and let me show you what happens when we turn this on. So I've got a little lab power supply here, and I'm just connecting it up now. Yeah. So this is the input wire. Yeah, there's a lot of gain there. Right, so you can hear the buzzing. Sounds like a small guitar amplifier. Yeah, there's an awful lot of gain going on there. So I think we are going to have to put some gain limiting in with this guy, which is generally why I always make sure I leave gaps between things, and also leave long leads on components that I know I'm going to experiment with. We have here a working LM386 amplifier, audio amplifier. So that is quite cool, and I'm quite looking forward to showing you that connected to the radio. Right, well, you might chuckle a little bit, but I couldn't help myself. Whilst I was waiting for these to come in, which is a TA7642. Just looks like a little transistor. It's equivalent to a ZN414. It's effectively a little AM radio on a chip. So I finished up the LM358, which is this little guy on the PCB right here, and I also added an OA91 little cat's whisker style diode, a little germanium diode, which is this chap right here. And I chucked a BC109 on their little preamp stage, little audio preamp stage. And then on top of that, I've also been doing a little bit of other work. The red knob radio now has lots of red knobs on it. So this here is the speaker. We've got the tuning capacitor here, and now we have volume control on that side of it as well. The other thing that I noticed was the ferrite rod coil that I had didn't seem to match the tuning capacitor very well, in the sense that it was sort of like halfway across the AM band. So I went ahead and wound my own coil, which is this guy right here. So then on top of that, what I've done is I've found an old lithium ion battery and a switch. I need to put a battery charge management circuit on that at some point, but this is the thing that you're going to be interested in. So it is quite selective, as you can hear, but it's a little bit distorted, and I've got a long antenna that I've got rigged up across the room at the moment, and that's the only way it works. If I disconnect that antenna, you literally receive nothing from this radio. So with a little bit of luck, one of these TA7642s, one of these will hopefully fix a lot of the problems that we're suffering from, primarily because it has a whole load of RF amplifier stages in it, which will really boost the signal. So with a ferrite rod, not an airspace inductor, this is an airspace coil here, but with a ferrite rod we should have a self-contained radio. Now, key thing about the ferrite rod is it won't work inside a Faraday cage. This is a metal box, which is ultimately a Faraday cage, so I'm designing a little plastic top for it at the moment, but that'll go with the sort of the 3D printed side of things. So let's adjust the circuit here to now include this AM radio on a chip. Much to the wife's dismay, I have brought the radio to bed and I'm tinkering with it, and it's great fun. I can listen to politics and sport and stuff, which I don't normally listen to, in all fairness. But yeah, well, I'm just going to go ahead and tune myself into something. So we're still a little bit off with our coil, because at this end of the capacitor literally nothing happens, and all of the action is at this end of the capacitor when the leaves are open. So this gives us minimal capacitance, which would indicate that perhaps there's too many turns on this coil here for the combination. So what I'm going to do, I'm actually going to rewind this coil, and it's a little coil transformer that goes on a ferrite rod. So here it is then, the winding of the coil. This is 0.25mm enamelled copper wire, and ultimately all I'm doing is putting about 40 or 50 turns of this copper wire on this coil former that I've made to go over the top of this ferrite rod. And then I will put probably another 20 windings on top of that, effectively to make a little transformer. But yeah, it should all look quite pretty when we're done. Well, there we go. So I had to unwind quite a bit of the coil, so I ended up with all of this here. And at the minute I'm just heat shrinking these, so I made it a little bit more permanent. But yeah, that works a treat. I've even calibrated it in the background there against another Roberts radio. So I'm confident that we're now listening to the appropriate frequency ranges. We've got the entire spectrum across the sweep of the capacitor. But there it is. There it is. So this is what we came up with in the end. So what we have then is a 220 picofarad capacitor with 40 turns on a ferrite core. Then the other side of that, there's 20 turns on the ferrite core, and we've got an option for an external antenna input, although you'll see we don't really need that. We've got a ZN414, which is a 6 or 7 transistor TRF RF amplifier and detector chip. This is a great little AM radio chip. It's designed specifically for this task. And then we've got a 1K resistor here setting the AGC, the automatic gain control of the ZN414. We've got a couple of little RF blocking capacitors here. And the supply for the ZN414 is actually taken from a 3.6 volt lithium ion battery here through a battery management circuit. But what I did is I used a 10K resistor and 2 diodes to peg this at 1.2 volts, because this operates up to about sort of 1.6 volts. So that's the power supply for it there. Then the drive output of that, now clearly that isn't a connection there, that is a connection there, but the drive output of the ZN414 goes into a DC blocking capacitor here, and that goes into an LM358 chip, which is an audio amplifier chip, purpose built. Oops, forgot that. I did actually put a capacitor there, a little 10 microfarad capacitor, 10 microfarad capacitor down to ground. And I've got a little log potentiometer here to adjust the gain. So normally the LM358 is set at times 20 as an amplifier, but this circuit here, this extra circuit here, gives you the ability to be able to turn that up to times 200, and that drives the speaker quite nicely, again through a fat hairy DC blocking capacitor. Another thing that I've forgotten here was actually there's a great big hairy capacitor for the power supply, which to be honest we probably didn't need. It's just sort of standard practice to put a big 200 mic capacitor in for the power supply. So the power supply is a 3.6 volt lithium ion battery, and that is going through a battery management circuit, which is supplying all of this exactly what it says on the tin, sort of 3.6 to 4.2 volts. And then here we have a solar panel connected to the battery management circuit as well. So this thing will never ever ever die. The ZN414 draws about 600 microamps. The LM358 only uses the amount of power depending on how much you turn up the volume. So normally you're probably looking at about sort of, I don't know, 20 milliamps, 100 milliamps, something like this, probably on maximum volume, bearing in mind this is only a 1/4 watt output. So there we have it. Right, Now go build one, guys. Trust me, it's been brilliant fun. I've loved every minute of it.
$7.99 a month subscription or something? Yeah, fine. I know. So Ellis, what are your 5 other things about BBC Sounds which you couldn't live without? I like feeling overwhelmed. Yeah. And I like knowing there's good people out there. That's nice. And I like how reassuring I find that.
So I was just wiring up the battery management PCB in the battery, and I wondered, is there enough power in the solar cell to be able to drive this without a battery? And guess what?
Golf caddy Craig Connolly. Who invented the skid?
How amazing is that? That is absolutely fantastic. So clearly the idea is to use the solar panel to charge the lithium ion cell, but as you can clearly see, this really doesn't use much current at all. And the great news is I mean, this is just going to be a radio for life, isn't it? I'm I'm loving this thing. This is awesome. So just designing the box lid right now, and we need to subtract the switch. This is the switch pattern here. 2 screw holes and the actual switch itself. We need to effectively remove that from the body. So this is using Shaper 3D, by the way, which I'm absolutely loving. Get rid of, and get rid of. And when we look at that, that all looks good. We say done, and boom, there we go. Now we have the switch hole in the lid. So the lid has been carefully designed to accommodate my weird and wonderful knobbage, my big red knobs on the outside, and now it has the switch. And then up in here, in this portion here, we will glue the ferrite rod. Good stuff. So here it all is. Look at that. Absolutely fantastic. A 3D printed lid, switch installed here. We're going to put the solar panel on that in just a moment. And where better to store the circuit diagram for this? For future possible repair work, not suggesting it's going to need any, but you never know. Let's just poke that down by the battery there. I'll keep everything nice and secure. Excellent stuff. Right, let's get the lid on.
I'm going to stress here, it was nothing out of hand, no one got hurt, no damage was done, but me and a mate ended up being apprehended. We ended up back at the cells. I decided it wasn't very serious, so I thought we were just going to get a slap on the wrist. Didn't call my parents, didn't take my right to the phone call, didn't tell them where I was. I thought I'd just get home, sneak in, be up for Christmas lunch. No.
Excellent. I've got something to show you.
Have you?
Yeah.
Really?
Yeah, something that I made.
Oh, really?
One of my crazy, wacky inventions.
What, this?
Yeah. Do you reckon you can have a guess? Do you reckon you can guess what that is? You can touch it. Go on.
Can I touch it?
Yeah.
Oh, it's heavy, isn't it?
Yeah.
Oh my God, that's fantastic. This is new, isn't it? What are you doing? That stopped as well.
Yeah, it stopped in that direction. Yeah. There's more knobs you can play with. Big red knobs that you can have a play with.
You watch it, else she'll be out through that door.
So can you have a guess what it is? What do you think it is?
I don't know. It's heavy, you know.
It is heavy, isn't it? Yeah.
You've got to think.
Hope you haven't broken it, have you?
I'm an old woman, you know. All these bones here are cracking up now.
So anyway, now you've had a play with the radio.
Yes.
Okay.
Yeah.
Can you tell us, when you were a kid, what did you have in the way of entertainment at home?
Nothing.
You didn't have a radio in the house?
Oh, in the house, yes. You had a radio.
Can you describe it?
They're usually very dark, very big, dark, wooden, you know, and then everything goes into that.
Yeah.
So that's what it was, really. But I mean, you know, it's nothing like they are these days, is it? So, you know, but they were smashing, absolutely fantastic. I mean, Mum and Dad and me as well, we used to dance.
Yeah.
You know, you get music in your radio, and then you can dance when you're in the room, and you know, the fun that you can have with it.
Yeah, yeah.
Marvellous, but it's not like that now, is it?
No.
It's totally different. So what have you done then?
Oh no, I just made a radio. I was just really happy that I was able to make a radio
the whole thing, then?
from scratch.
Oh, wonderful. Do you know, I always loved the radio better than anything.
Yeah.
Better than, you know, I mean, it's all well and good saying, oh, but that's finished now, that's finished. For me, things are never finished.
Yeah.
I've always loved these things, and I think I should have been a boy.
I'm sort of glad. I'm glad you weren't, because you wouldn't have had me then, would you?
That would have been a damn nuisance, wouldn't it?
Anyway, thanks ever so much for watching, guys and girls. Take care. Have a wonderful week and weekend. Don't forget, thumbs up, subscribe, and we'll see you again in the next video. Cheers.
We'll pay you next time.
Cheers and beers. Bye for now.